To take the derivative of something like natural log of 3x cubed minus 2x squared plus 4, we need a very, very specific rule. So the logarithm rule for natural log, taking derivatives of the natural log of some function, let's call it g of x, is always g prime of x divided by g of x. Which means that if I want to take the derivative of just natural log of x, I always get 1 over x, because it's derivative of x, which is 1, divided by x. So that's a really, really important rule because, it works just like all our other rules with if there's a 3 out front, then this becomes a 3. And the g prime over g is just easier than writing or doing the chain rule. It's easier to memorize it as this rule, g prime over g. It is the chain rule, however. It's the rule where we do 1 over the crazy stuff times the derivative of the crazy stuff. The derivative winds up in the numerator, though, because 1 over g of x times g prime of x will look like g prime of x over g of x. So if I use that rule to take the derivative of natural log of 3x cubed minus 2x squared plus 4, it looks like, well, the derivative of the numerator is 9, or the derivative of the inside is 9x squared minus 4x, and the denominator is just what's inside the parentheses. Done. There's my derivative. So another example, if I want the derivative of natural log of 18x squared minus 1 over x plus square root of x. I know my derivative, well, the denominator is just going to be all that stuff. And the numerator is going to be the derivative. So 36x. Now, negative 1 over x is negative x to the negative 1. So that's going to be plus x to the negative 2. And root x is x to the 1/2, so that will be plus 1/2 x to the negative 1/2. And of course, you can simplify the numerator, but otherwise, that's my answer. Another thing you can be asked, like always, is to write an equation of a tangent line. So if I'm writing the equation of the tangent line to y equals natural log of 2x minus 1 at x equals 1, not a half. Then what I'm going to do is, just like always, I'm going to take the derivative, which is going to be 2x minus 1 in the denominator, and in the numerator, it's just 2. To find the slope, I plug 1 into that, so 2 over 2 times 1 minus 1, which is 2 over 1, so 2. And then I do my standard form, so y minus, let's see, well, if I need a y value, I plug 1 into here. So I get natural log of 2 times 1 minus 1, which is natural log of 1, which is 0. So y minus 0 equals m times x minus 1. And if you're writing in y equals mx plus b form, that's y equals 2x minus 2. I recommend, if you're doing point slope, you don't need the minus 0 anymore. So that's how we use natural logs in equations of tangent lines. One other thing that you need to know that will help in a lot of different places is if I give you an example that looks like this. Derivative of natural log of x plus 1 over x minus 2. Notice that if I do the derivative like I'm supposed to, this is my denominator. And my numerator, in order to do the derivative of what's inside, needs the product, or the quotient rule. So it's the derivative of the first times the second minus the first times the derivative of the second, all over the denominator squared. This is crazy messy. I should simplify this because if this was a multiple choice question on the AP, it would not look like that. So the numerator is x minus 2 minus x minus 1, so that gives me negative 3. I've got this x minus 2 squared, and then that other fraction, if I flip and multiply, looks like this, where one of each of these cancels. So it's really negative 3 over x minus 2 times x plus 1. And then again, if I have to write an equation of a tangent line or something like that, that'll work out. The other thing that I want you to notice, however, is this same logarithm can be done with our log rules. If you don't remember log rules, this is a good thing to write down. The rules are, if you have natural log of a over b, let's start with that one, you get the natural log of a minus the natural log of b. If you have the natural log of a times b, it's the natural log of a plus the natural log of b. And if you have natural log of a to the b, it's just b times the natural log of a. Those are the very, very important rules for logarithms. It's a way to rewrite them. Why is that important? Well, for this example, it makes our lives easier, because if I have a fraction, this is the same as natural log of x plus 1 minus natural log of x minus 2. And when doing the derivative of that, notice now I don't need the quotient rule. To take the derivative, I just use the derivative of natural log rule. So this is over x plus 1, so that's for this one. And the derivative of x plus 1 is just 1. It's minus the derivative of this guy, which is over x minus 2. Derivative of x minus 2 is also 1. If I try to add these fractions together, I get x minus 2 minus x plus 1 all over x plus 1 times x minus 2, which gives me x minus 2 minus x minus 1, which should look familiar. Both methods are correct, but logarithm rules actually makes it faster and easier, because this is a perfectly good answer. You don't actually have to simplify it, but you can. If it was a free response question, you're done. If it's multiple choice and it looks like this, all you have to do is add pretty simple fractions. So here's one more huge example of doing derivatives with natural logs. If you'd like, you can pause it and try it and then come back and see the answer. Otherwise, I'm going to do it right now. Notice that the first one is x times natural log of x, so I have to use the product rule in order to do that derivative. So the derivative of f is 1 times the derivative of g, or times g, not derivative. So derivative of the first times the second plus the first times the derivative of the second. Again, if you look back, the derivative of natural log of x is just 1 over x. Plus, now here's the thing, I could do this derivative and I'd have to do product rule on the inside. If I don't feel like doing that, I can write this as natural log of x squared plus natural log of cosine x. So when I take its derivative now, I do the inside function divided into the derivative of the inside function, plus derivative of cosine is negative sine divided by cosine. There's some stuff that you can simplify here. Those cancel. A negative sine over cosine is negative tangent. So this final answer, if I were to sort of simplify it, looks like this. It's crazy ugly, crazy messy, but this part was actually easier because of my logarithm rules. And that's everything that you need in order to be able to do derivatives of natural logs. One more final basic logarithm rule example, just to make sure you understand it. Okay, the derivative of this is just the derivative of the inside, 50x to the fourth minus 15x to the fourth, 50x to the ninth minus 15x to the fourth plus 12x all over the inside function. If you understand that, you can work with everything.